now we can talk about the gradient of a line. The gradient, when we consider our diagram there, we have points A, B on our Cartesian plane, having the coordinates here. B has those ones there, and then A has x1, y1. The gradient is going to be equal to a change in the y all over change in the x values. The x values, I mean the values on the x-axis. Then y values, I mean values on the y-axis there. So my change in the y values here, these are the values there. y2 minus y1 all over change in the x values there, x2 minus x1 there. So that gives me my gradient. Now I'm going to temporarily call it M, and as we are going on the way, we shall be talking about that M there as the gradient. So another person can say that my gradient is equal to y1 minus y2 all over x1 minus x2. We both shall get the same answer and of the same sign there. So our first example there, find the gradient of the lines passing through the following points, part A up to part C there. So my part A there, I'm having these 2 points there, and the gradient is going to be equal to y1 minus y2 all over x1 minus x2. Then I need to come here and then nickname my points there. This is x1, y1, x2, y2 there. So when I substitute, y1 is negative 12 minus y2, which is minus 9, divided by x1 is a 4 there, then minus x2 is a 3. In the numerator, this one here is going to become a positive, then I end up having a negative 3 there, then divide by the denominator. When I subtract, I have a 1, so negative 3 divided by 1, I get the answer as negative 3 as the gradient. So the other person who used the gradient as y2 minus y1 all over x2 minus x1, when you try to substitute using the notions there, this is my y2 negative 9 minus the negative 12 divided by x2, which is a 3, minus x1, which is a 4. The numerator, this one here, negative negative gives us a positive. Negative 9 plus 12, we get a positive 3. Then divide by the denominator. When I subtract, I have negative 1. So positive 3 divided by negative 1, I get the answer as a negative 3. So you can see that we are all getting the same answer. Even if you interswitch here, it doesn't matter, we shall be getting the same answer. My part B there, to get my gradient, this is going to be equal to my y2 minus y1 all over x2 minus x1. I nickname x1, y1, x2, y2. So when I substitute here, y2 is a 4 minus y1 is 6 divided by x2 is a 6, then minus x1, which is a 9. So in the numerator, I have negative 2 there, and also in the denominator, I have a negative 3 there. So negative divided by negative, that one we are going to be getting a positive. Therefore, the gradient is 2 all over a 3. My part C, there, I have my points there. I've nicknamed them. Then that is the formula of getting the gradient. So when I substitute, y2 is 3 all over 4, then minus this one 2 whole number and a half, converting it to improper. This is going to be equal to 2 times 2, that is a 4 plus 1, that's a 5 all over 2. So minus 5 all over 2, then divide by the denominator, that is going to be x2, which is a half, then minus a 6. Now, we looked at how to deal with fractions there. In a numerator, I'm having the LCM there as a 4, then times a 4 here, times a 4 there. When I compute that, I'm having a 3 because the 4 cancels. Then when I compute this one here, 2 goes into 4 twice, 2 times 5, that's going to be minus 10. Then there is a division of a half minus 6. The LCM there is a 2 again, times 2 and then times 2 there. So this one here I'm having 1 minus a 12 there. So this one here is going to be equal to, in the numerator when I subtract, I'm having negative 7 all over 4 divided by negative 11 divided by 2. So this one, to change the sign to become a multiplication sign, we take the reciprocal the other side to be negative 7 all over 4 times negative 2 all over 11. So this one here is going to be equal to, the 2 is going to reduce that, and then the negative times negative shall be getting positive. So this is a 1, that is a 2. 7 times 1 is 7 all over 2 times 11 becomes 22, and that one there becomes the gradient of the line passing through these 2 points there. Example 2, find the value of A if the line joining the points 2A and 4, 5 is a third. Now, we are going to find that value using our knowledge of the gradient. We have been given the gradient as a third. We have been given these points. So I remind myself the formula of getting the gradient. So that is y2 minus y1 all over x2 minus x1. Now, I need to nickname my points there. This one here is x1, y1, x2, y2. Then I come down here, I substitute them to give me a third, because this is all the gradient. That means that even the whole of this is equivalent to a third. So this one is going to be equal to, a third is equal to my 1, y2 is 5, then minus y1, which is a, divided by x2, which is a 4, minus x1, which is a 2. Now I'm having 2 fractions either side, so I can cross multiply. So the 1 is going to multiply the 4 minus a 2, then is equal to a 3 to multiply 5 minus a. So here, so 1 times anything is that anything. 4 minus 2, I'm having a 2 there, is equal to this side, when I open the bracket, I'm having 15 minus the 3a. Then I take the negative 3a, the other side, and I bring the 2 this side here. So this is positive 3a is equal to positive 15, and then this one was positive, crossing equal sign, it's now a negative. So I'm having my 3a is equal to, when I subtract here, I get 13, then I divide both sides by 3, and that way by 3. So I get the value of a as 13 all over a 3. Our example 3, find the value of p if the line passing through points that one and that is 5. Now we are going to do the same thing as in the previous example. We have been given the gradient as 5. I have my points p comma negative 9, then negative 2, 1. So I nickname 1 x1, y1, x2, y2. Then I know that my y2 minus y1 all over x2 minus x1 is equal to the gradient. Now I can substitute these ones there and also the 5 there. My y2 is a 1 minus y1 is negative 9 divided by my x2 is negative 2 minus x1, which is p, is equivalent to a 5. So this one here becomes a positive, and now addition to get 10 divided by this one here, there is a figure and an unknown, is equivalent to, the other side is 5, and this 5 is all over a 1. So we are going to cross multiply. 10 times 1 is equivalent to 5 times the negative 2 minus the p. Opening brackets this side, this is going to be negative 10 minus 5p is equal to the other side 10. So when I take the negative 5p the other side to become a positive, I take the 10 this side to become a negative, so minus 10, then minus 10 there. This side here, when I compute that, I'm having negative 20, and the other side I'm having 5p. So divide both sides by 5, and then 5. I end up getting my value of p as negative 4.